This is how you currently travel from Hamburg to Copenhagen. But what about this new path? A gigantic undersea tunnel is set to take over this task, and all of Europe will be transformed after this. Welcome to the current under construction Fehmarnbelt fixed link. Surprising fact, this single looking tunnel is made up of many individual elements. The engineers had to lower these gigantic concrete elements with utmost precision with the help of strand jacks. One strong ocean current and the entire Fehmarnbelt project could be in jeopardy. In this case, the engineers should be able to straighten the element. How can they do it just by pulling it from the pontoons? Engineers are tricky. Look at this mooring rope which is anchored on the ocean bed. Can you tell what will happen if this rope is pulled upward? When you pull a rope, it naturally seeks to straighten out. Yes, when the mooring rope gets straightened, the element automatically becomes straight. Engineers are smart, right?
If you want an experimental proof, just a vertical pull. Wow, the element straightens like a magic.
A strand jack connected to the pontoons does this pulling up job. If you need to move the element to the right, you pull both guidance cables. As the cables shorten, the element has no choice but to move right. To move in the opposite direction, simply activate the cables at the other end. By utilizing these guidance cables, engineers achieve full 2D mobility during the immersion process. Simple, yet genius engineering. Now, you might be wondering, despite being individual pieces and being under severe hydrostatic pressure, how these tunnel elements are leak-proof. The answer lies in a clever technique used by the engineers. This is the previously lowered tunnel element. The first job is to inspect this element using an ROV. If the ROV finds the edges of the element are not clean, the underwater divers have an important task to do. They have to clean the edges of the tunnel elements using high-pressure water jets. Observe carefully. Very soon, a water chamber is going to form between them. First, pulling jacks are installed between the new and the previous element. The pulling jacks are now activated and the elements close. Please pay special attention to this large rubber seal called a Gina gasket. Once the pulling jack is activated, the Gina gasket gets compressed and forms a preliminary watertight seal. Now, you can see that some water is trapped between the two elements, forming a water cavity. Engineers now pump out this water. Can you tell what will happen now? The pressure inside this chamber will become negative. The high pressure from the outside will automatically force the elements to bond more firmly, an automatic bonding between the elements without using any external machines. Now it's time to bond these elements permanently. By maintaining the negative pressure, the workers first install omega seals on the joint. Next, they seal the joint region permanently by pouring concrete. Now they can remove the bulkheads and the pressure will become normal.
Here comes the big question. How can the workers enter the bulkhead chamber to do the omega seal work? As soon as they open the bulkhead door, the negative pressure will be lost and the elements will be loose again. In fact, this does not happen. We are missing an important point here. The pressure at the bottom of the Fehmarnbelt is 5 times that of the atmospheric pressure. And the pressure inside the tunnel elements is always kept at 1 atmospheric, so that there is no issue for the humans working here. This means even if the pressure increases to 1 atmospheric pressure inside the tunnel element, it is still lower than the outside water pressure. This way, the joint will remain intact.
The Fehmarnbelt project has an interesting innovation. Some of the elements have double-decker geometry. Can you guess why? The lower deck is not for traffic. It is used strictly for mechanical and electrical equipment such as transformers, switchgear, pumps. The Fehmarnbelt project has 10 such elements. They are called special elements. The special element is slightly wider and has a lay-by. This allows the maintenance crew to park their vehicle in the lay-by without disturbing the traffic and access the lower deck via this door. In short, Instead of spreading the complex machinery along the tunnel, they kept them in specific tunnel elements below the ground. You'll be surprised to know that the 18-kilometer length Fehmarnbelt is made up of just 89 tunnel elements. That means each element must be of incredible length. Yes, the length of one element is a whopping 217 meters. The bulkheads you see at the ends of the tunnel elements are real heroes. They are temporary structures, but make sure that the elements remain leak-proof during the immersion.
How these huge structures, the bulkheads are removed. Engineers need to reuse the bulkheads for the new tunnel elements.
For the removal of bulkheads, the tunnel should get access to the entry and exit portals. Once the element placement progresses and reaches this stage, an interesting machine makes its entry, the BLRT. The machine enters via a portal. Now, BLRT stands stable on its four legs. The real magic starts now. Using its arms, the machine lifts and rotates a bulkhead. The rotation is so crucial. You can see the bulkhead is not colliding with the nearby bulkhead. The BLRT has a clever mechanism to achieve this. We fabricated this mechanism with precision to understand it. These two hydraulic pistons are the most crucial part of the mechanism. The website JLC CNC helped us with this experiment. They have over 600 CNC machines at their disposal, with 4-axis and full 5-axis capabilities. After finalizing the CAD model, you just need to specify the material and place the order. In case of any issue with the model, the expert team from JLC CNC will help you rectify the problem. I received this box 1 week after ordering. And look at the quality of the machining. It's satisfying to watch how smoothly this piston goes into the cylinder. Wow, when we operate both of the pistons together, without consuming much space, the bulkhead is rotated 90 degrees. The bottom piston is the trickiest one. You can see a small triangle here. The cylinder is hinged here. When the piston expands, it pushes and rotates the bulkhead. You can also notice that this point is going up. This means the cylinder has no other way but to rotate downward. This way, the bulkhead achieves the 90-degree rotation. During this operation, the top piston would retract its length. This means without consuming much space, the rotation is completed. The machine can even keep the bulkhead on the BLRT. The removed bulkheads are now kept on a trailer, and the trailer starts its reverse journey. This way, in a progressive way, all the bulkheads are removed. Now, you might be wondering how they fabricate these 200-meter-plus length concrete elements. Fabrication of these gigantic elements and their transportation is the real innovation of the Fehmarnbelt project. The Fehmarnbelt Fixed Link project features one of the most massive casting facilities ever built. The casting facility is located near Rodbyhaven on the island of Lolland, Denmark, spreading over a massive 150 hectares of area, an equivalent of 300 football fields. Rebar used in one tunnel element is staggering. If we add the length of all these pieces, it is around 350 kilometers long. They use reusable formwork, and a huge amount of scaffolding and support is needed to support these forms. Some forms are even hydraulically powered. Once the rebar and form arrangement is complete, the concrete is poured into the cavity. Engineers now need to wait for the curing of the concrete. After this, the forms can be removed. The length of the section just made is around 24 meters. We know each tunnel element should be 217 meters long. The trick is to move this small element forward on tracks using a hydraulic skidding system. Have a look at the hydraulic machine which does this pushing operation. Once the element has moved a distance of length of the section, The next casting is done in the same location. In this way, the final tunnel element length is achieved in 9 phases. The entire production takes place in massive climate-controlled halls. The reason is that concrete curing is highly sensitive to temperature and humidity. Such stringent quality measures guarantee a lifespan of 120 years to the concrete elements. You can see they have built huge tanks inside the concrete element. We will understand their purpose later.
Why is there a crowd and celebration behind me? Today, on June 17, 2024, the first tunnel element was completed in Rudivand factory, and this is being inaugurated by King Frederick X of Denmark. You can see a time capsule box near the king. The plan is to bury it near the entrance of Danish site. This time capsule box contains items such as coins featuring king's image, paintings by local children, and message from the workers who built the first tunnel element. The tunnel element is absolutely huge, right?
Once the concrete is cured, each end of the tunnel element is sealed with the bulkhead. When the tunnel elements are ready, the basin is flooded with water from the adjacent waterway. These bulkheads ensure the inside of the tunnel element remains dry and air-filled. The concrete segment is designed so that when it is airtight, it floats on water, a clever use of the principle of buoyancy. You might have noted that along with the flooding of the basin, the ballast tanks inside are also partially filled. This is an operation called trimming. Without the trimming, if you directly flood the basement, the element will float, but there is no guarantee it will float straight. With the clever ballast tank filling, the element is floated perfectly straight and also with the exact amount of immersion needed. Please note that the weight of one tunnel element is 73,500 tons. They cannot be transported via road. Once afloat, the massive tunnel elements are towed out of the basin by tugboats. The element's top surface is just 30 centimeters above the water's surface. The elements are first towed to the work harbor. In the work harbor, the hero of the Fehmarnbelt, Ivy, is waiting for the tunnel elements. These are custom-made pontoons specifically designed for the Fehmarnbelt project. The first task is to hand over the element to the Ivy. Now it's time to reveal the next ballast tank of the tunnel element, concrete ballast tanks. They are hidden inside the element. After securing the element with the Ivy, engineers fill these concrete ballast tanks. Now, the element is too heavy and no longer positively buoyant, but the connection with Ivy will make sure that the element will still float. Now, the long journey of the Ivy, along with the element, towards the immersion site starts. They are going to place the tunnel element on the seabed. To place these tunnel elements, the seabed has to be ready. The seabed needs to be excavated into a perfect trapezoidal shape with a well-prepared foundation. How did the engineers achieve this in the deep ocean? These huge dredges are performing the most crucial job of the tunneling project. They are preparing the seabed for the placement of the heavy tunnel elements. Clamshell dredgers are used for this purpose. Most of the material was excavated by a trailing suction hopper dredger. They remove sediment and prepare the seabed in a trapezoidal shape. A layer of granular material, such as gravel, is placed in the trench to create a smooth, level, and firm surface for the tunnel to rest on. The tunnel element King Frederick X inaugurated was successfully immersed on the 6th of May 2026. The immersion took 14 hours to complete. The immersion process is in complete control of Ivy. Even the pontoon is anchored to the seabed. Once properly placed above the right position, the engineers lower the element by activating the strand jacks. Please remember, at this stage, the element is no longer buoyant. We know the remaining process of precise alignment using mooring ropes. The actual immersion of the standard element was delayed by approximately 2 years. This is due to technical challenges and testing requirements for the specialized immersion vessel Ivy. This animation illustrates how different tunnel elements will be added and how they progress. You may observe special elements in this animation. The tunnel technology we have just understood is known as the immersed tube tunnel. The Fehmarnbelt tunnel is a missing link in the ScanMed corridor. Currently, the Copenhagen to Hamburg train journey takes 4.5 to 5 hours. When this tunnel is complete, this traveling time will reduce to a mere 2.5 hours. The missing link looks tiny, right? Currently, ferries are operational in the missing link. Transportation via ferry takes anywhere from 45 to 60 minutes, plus an additional 15 to 30 minutes is required for check-in and waiting at the ferry terminal. Post the Fehmarnbelt fixed link, this travel time will reduce to 10 minutes by car and just 7 minutes by train. You might now be wondering why the engineers didn't choose a bridge option to complete the missing link. In fact, the very first proposal was a bridge, a cable-stayed bridge. If this proposal was approved, this magnificent cable-stayed bridge would have become the longest cable-stayed bridge in the world. Why was this proposal rejected? The Fehmarnbelt is one of the busiest shipping lanes, with approximately 42,000 to 70,000 vessel transits per year. Even if the engineers provided a massive span for the bridge, a ship collision was a major concern. Moreover, such a bridge would require a 65-meter vertical clearance. The navigational risk is effectively zero for a tunnel. The environmental impact of a tunnel is much lower than that of a bridge. A bridge has a permanent footprint on the landscape. It is true that the tunnel requires dredging a massive trench, but the impact is largely temporary. Over the years, nature will automatically take over. The most important reason is the gradient challenge. You can see that the first half of the bridge is a gradient climb. In a heavy rail context, even a 1% to 1.5% gradient is considered significant. Since the bridge has to be at least 65 meters above the sea level, the gradient was significant. If a heavy freight train is forced to stop on a 1.2% bridge incline, restarting it requires massive tractive effort, even a chance of wheel slip. The tunnel also has an up gradient in the second half, but the lowest point of the tunnel is just 40 meters below the sea level. This results in much lower gradients. Now, you might be wondering why the engineers didn't opt for a TBM tunnel like Channel Tunnel. At a maximum water depth of 30 meters, there was no need to build a TBM tunnel. TBM tunnels are preferred for higher water depth regions. For a low water depth region like Fehmarnbelt, the immersed tube tunnel technology is the practical solution. You might have an interesting question in your mind. How do workers enter the tunnel element after the immersion? With the current element geometry, it is not at all possible. The trick is patience. The workers have to wait until the elements progress and reach the portal. Now the workers can enter inside the tunnel and do the remaining work. Of course, with the help of BLRT, they can easily progress forward. The casting factory in Rodbyhaven, Denmark has now reached serial production speed. While the first element took nearly a year to cast, the facility is now aiming to produce one full element every few weeks. The Danish project owner, Fehmarn AS, and both Danish and German governments officially maintain that the tunnel will open to traffic in 2029. Construction has been running 24/7 at the factory in Rodbyhaven to keep this date viable. The process of immersing the elements faced a setback. The custom-made immersion vessel Ivy was delayed by approximately 24 months during its testing and approval phase. Many industry experts now suggest that while the tunnel structure might be finished, the commissioning for traffic could shift toward 2030.
Anyway, once complete, Fehmarnbelt will be the longest immersive tunnel in the world, a revolutionary project for Europe. Let's all wait for the completion of this beautiful tunnel and a pleasant journey through it. Before you leave, please don't forget to check out the website jlccnc.com for any of your CNC needs. Take care. Bye-bye.